What is going on, guys? My name is Amos and I'm back again with another video. So this is where we ended in the previous video. So this was our decomposition in R. Now we want to see how we can decompose F1 in C. Now this is okay. Now this is okay. This is also okay. Now this, we can develop it a little bit further. So we can basically find, a decomposition, of this. So here, this we're going to call F3 or F2. We're going to call it F2, right? And then we'll try to see how this can be decomposed in C, because this denominator x squared plus 1 is no longer going to be irreducible. It is irreducible in R, but it is reducible in C. So here we're going to first of all see how we can, decompose F2. And then when we decompose F2, we're going to throw back the expression here. We're going to throw it in, and then we're going to get our F1 here. So that is what we're supposed to do for us to get the decomposition in, C. Right. Now let's look at how that is going to be done. So that is our form. So here we're going to say F2 is equal to 3x plus 4 divided by x squared plus 1, like so. So this is our F2. Now this is going to be equal to 3x plus 4 divided by, now this x squared plus 1 can be decomposed in C in the following way. So here we have x plus I, and then here we have x minus I, like so. So this is what we have. Now this is going to be equal to a certain beta 1 divided by x plus I, and then plus a certain beta 2 divided by x minus I, like so. So this is how this can be decomposed. So now we have to find the value of beta 1 and the value of beta 2, and then we're going to substitute for beta 1 and beta 2 in this expression, and then we're going to get that expression and put it back in F1. That is going to be the decomposition of our gigantic F1 in C, right? So that is what we have here. So here I'm just going to get rid of, I'm just going to get rid of this part here. I'm just going to get rid of that part here. And then to find the value of beta 1, we have to multiply by x plus I throughout. And then we're going to choose a value of x that is going to make the other quantity that has beta 2 0, right? So here, if we multiply by x plus 1, here we're going to have x plus I multiplied by beta 2 divided by x minus I. Now here we're going to choose x is equal to minus I, and here the denominator is going to be non-zero, so that is going to be good information. And then here we're going to have 0, right? So meaning the numerator is going to be 0, the denominator is going to be non-zero, which is a good situation. So here we're going to multiply by x plus I, and then we're going to choose x is going to be equal to minus I. So here we're going to have x is equal to minus I. So basically here we have minus 3i plus 4, yeah, right, minus 3i plus 4. Now this is going to be this is going to cancel with, this is going to simplify with the x plus I that we're going to multiply. So here, this is going to be, x is going to be minus I here. So here we should have minus 2i. Now here we are dividing two complex numbers. Now here we can write the complex number that is at the bottom as 0 minus 2i, because the real part of the complex number is 0. Now whenever you're dividing two complex numbers, you have to multiply by the conjugate of the denominator at the numerator level and at the denominator level. That is how we're going to get your simplification. Now this is what beta 1 is going to be equal to. Now we're going to multiply by the complex conjugate of minus 2i. Now the complex conjugate of minus 2i is gotten by changing the sign of the imaginary part. Now here we should have 2i and then divided by 2i, like so. Now this is going to be now 2i multiplied by minus 3i. Now first of all, 2 multiplied by 3, 2 multiplied by minus 3 is minus 6. Now I multiplied by I is I squared, but I squared is equal to minus 1. So it is minus 1 multiplied by minus 6. That is going to give us 6, like so. Now this is going to be plus 8i. This is going to be plus 8i. And then this is going to be now divided by. Now here we should have minus 2i multiplied by minus 2i. Now this is minus 2 multiplied by minus 2 is going to be positive. Minus 2 multiplied by positive 2. So here we have not minus 2 multiplied by minus 2, but minus 2 multiplied by positive 2. Remember, we've changed the sign here. So here we should have minus 4i squared. Now I squared is minus 1. Now minus 1 multiplied by minus 4 is going to be positive 4. Now that is good. Now here we're going to have positive 4, right? And then we divide that positive 4 throughout, like so. Now here we should get 3 over 2. Here we should get 3 over 2, and then here we should get plus 2i. So that is going to be our beta 1. Now, without wasting much of your time here, I'm going to tell you that beta 2 is going to be 3 over 2 minus 2i. Why? Now, this is because beta is going to be the complex conjugate of beta. Beta 2 is the complex conjugate of beta 1, and beta 1 is the complex conjugate of beta 2. Now, if you look at these two fractions that we have here, so that should give you an indication of this result. Now, you can also calculate, you basically find the same results. So we're going to get this beta 1 here, and then we're going to substitute it here. We're going to take this beta 2 here, then we're going to substitute it here. Now that should give us our 3x plus 4 divided by x squared plus 1 in C. That is the decomposition of this rational fraction in C. Now to find our f1, we have to get this second form here. Now I'm going to change my color here. So we're going to get this second form here and see how this is going to be substituted here, because we just have to substitute this there, and that should give us our f1 in C. Thank you guys for watching, and I'll see you in the next video.